Let's take a look at some properties of quadratic functions. So quadratic functions are going to graph parabolas for us. They can either be opening upward or downward. So let's find some of these following characteristics based on this function 4x squared plus 14x plus 6. So finding the y-intercept, that's going to come from plugging in 0. And with that, everything should wipe out except for that last value, which we call c. So in this case, that would be 6. So this is giving us a coordinate 0, 6, which let's go ahead and graph that. So 0, 1, 2, 3, 4, 5, 6. Finding the vertex of the function. So to find the x-coordinate, we use negative b over 2 times a. So with our scenario, we'll have x equals negative 14 over 2 times 4. This is going to be a fraction, negative 14 over 8, which will be a negative 7/4. And let's get a decimal approximation because what we're going to end up doing is graphing. So that'll be a negative 1.75. And for our coordinate, then what we would want to do is to find the y-coordinate, we would plug it in. So we're going to do 4 times negative 1.75 squared plus 14 times a negative 1.75 plus 6. And I messed up in my calculator one more time. Negative 6.25. Okay, so we have this coordinate. I'm just going to draw it as best I can. 1.75 and then negative 1, 2, 3, 4, 5, 6 with a little bit there. Okay, write the factored form. So what we're going to do is take our function and let's see, I have a common factor of 2 that I can get out of there. So that'll leave me with 2x squared plus 7x plus 3. And then we'll go ahead and factor. We could use AC method or whatever methods we have. This wouldn't be too bad with trial and error because we would need 6 plus 1 to get that 7 in the middle. Okay. Finding the factored form is right there, and then what are the x-intercepts? That's where we take each of these factors and set it equal to 0 and solve. So we'll have x equals negative 1/2. We'll also have x plus 3 equals 0, which is x equals negative 3. So we'll have negative 1/2 as a 0, and then at negative 3 we'll have a 0. Okay, so we have our sketch of the function going, and what we could do is go ahead and just connect those dots. So that vertex should be the minimum here, and then everything else will just go on. Axis of symmetry, so that's this line that goes through our vertex, because if we fold our paper right there, it should land on top of itself. So that should always be the vertical line that goes through the x-coordinate of the vertex. Okay, so there's one way of finding those properties. And let's talk about what happens if we're given vertex form. So finding the y-intercept, we'd be plugging in 0. This will have a little more work to do with it as compared to the last one. So let's see, we have a negative 3 times 4, and then we're adding 3. So this is going to be at a negative 9. So we have the coordinate 0, negative 9 down here. For the vertex, that gets easier here. So this is going to tell us about the x-coordinate. This is going to tell us about the y-coordinate. Now something to notice is in our general form, we expect to have subtraction. So whatever the x-coordinate is, we want to change the sign there. So because it shows a positive 2, my x-coordinate is going to be a negative 2. So I would have like a minus a negative 2 to see that plus 2. And then the y-coordinate just stays the same, so you don't need to change anything there. But it's like we talked about with our graph transformations, kind of opposite when we put things next to x, and that's what's happening right there. So our vertex, no calculation to do, we're just reading from the function itself that we have a negative 2, positive 3. So -2, +3. Writing the factored form, what we're going to need to do is multiply everything out. So I have a -3 times that x plus 2 squared. As a good reminder, make sure to think of that as x plus 2 times x plus 2 is not equal to x squared plus 4. We need to FOIL that out. And that should leave us with an x squared plus 4x plus 4. And then we have that plus 3 on the outside. And then we'll go ahead and simplify. So distribute the -3 in. Add that 3 at the end. And factor out a -3 out of everything, and that should be an x squared plus 4x plus 3. Factor with the x plus 1, x plus 3. And then what we would have is an x plus 1 equals 0, which would give us x equals -1. X plus 3 is equal to 0, so x is equal to -3. So we get our two zeros, one at -1, one at -3. And then with that, and actually with symmetry, that y-intercept wouldn't be bad to get another point with right there. And then we have our parabola opening downward, going through our zeros and the y-intercept. And the axis of symmetry, again, we look at that x value from our vertex and we use that to make a vertical line.